this is not easy, the project. However, comparing to the project offered in the operating system, other university definitely is easier than such a project. Okay, so because we are not going to use the kernel, so you don't have to compile the rebuild the kernel that fit to the at the time your programming language is very limited to implement your algorithm like the file system or the CPU scheduler. So you need to use the C or the C++. Sometimes you need to use assembly language directly. Okay, this is a much easier project comparing to other university. Yes.
I have a question about the project.
Not details what the algorithm, just
No,
the overview. Yes.
What do you mean by put the command put R remote?
Comment means I got a couple of the question from the couple of students, same question. So comment means, so this is a test file. I'd like to add a comment, like when you add a comment to the Microsoft Excel sheet. So you can add a comment to the each file on your PFS, portable file system. So where can you store such a comment? In the file control block that you are going to design. Okay, so for example, you upload put a.txt file. Okay, then you can add a command like this is a test. So where if you run this command, this is test, such a command will be added to the part of file control block. Okay. It's not your original file on your file system like the NTFS or whatever. It's only in the portable file system. Your file data itself is never changed. You can just, it doesn't matter whether this is a text file. Some of the students still got confused whether this is a text file or not. No. So the computer point of view is nothing but text file or binary file, IND file. Everything is a binary file. It's nothing but 0 or 1. Okay? When you upload or when you download, you can just transfer the whatever the file format is. It's just binary. Okay? Just bit by bit, you can transfer byte by byte. So you can transfer such a data. Okay? And yes.
Other question about bootc, my file run command. Bootc.
Yes, that's a comment.
There is an associated program to be run against this file. What does that mean?
Let's see.
Last page. Bootc.
Where's the pussy?
Last page.
So, for example, DOC file, what do you need? Microsoft file. Okay, so where can you manage such a thing? In your file control block, not in the file. Okay, using what? Extension. So that is the additional information. It's kind of the comment, but there is additional information to link or to give the information about what program you can execute this file. Okay, it's additional.
Okay, the number associate the program, there is a 10 extra point. 10.
Yes, it's an extra point.
Yeah, it's associate program would be is the second extra point. Extra credit, sorry.
Yes, using this one. Okay, then if you run this program, okay, file, for example, a.txt file, then txt file will be recognized by your portable file system. In your file system program, you can actually run Notepad. Okay, then by downloading first you need to download the file to your temporary space on your hosting file system, then execute the Notepad, then with the parameter probably input is the my file. Okay. Any others? Okay, thank you. And I hope to see you the project week on the after Thanksgiving. Okay, so today we are going to finalize the virtual memory, which is the page replacement mostly. So last class we have seen different algorithms for the page replacement. So we are going to use such a reference string. Reference string means it indicates the page 1, refer the page 1, page number 2, page number 3, something like that. So we have the two reference strings. Okay, so this is the first in, first out algorithm, which means when we select the victim. So this is actually the physical memory. So how many page frames we have in this physical memory? So 4. In this case, 3. Okay? Then we'd like to, in the reference string, probably the program has 5 pages. Okay? In the logical, the memory. It's a program. It's a process. Okay? However, since we have limited page frame, physical memory, we need to page in and out. Okay, that is the idea of the page replacement. Then, when we select the victim page, which means which page frame will be replaced by the incoming. So at that time, we can use the first in, first out algorithm, which means in this case, don't forget the first 1, 2, 3 cause also page fault. Why? Because we cannot find the pages from the memory. So 1, 2, 3. Then once you refer the page frame number 4, there's no 4, so you need to select one of them as a victim. That is 1. Of course, it's the first thing. So that is the first thing in, first out. So you can do the same thing for the another reference string. Delay is normally means the more page frame, the bigger size of the page we have, we probably guess the better performance, which means less number of page fault, right? But it's not always true. Sometimes, even though we have the bigger size of the memory, it causes the 10 page fault. So, which means depending on the algorithm and the reference string pattern, maybe different. That is called the delays anomaly. Like this one, we expect like this one, but sometimes we have the anomaly. That is called the delays anomaly. The next algorithm that we discuss is the optimal algorithm. So optimal algorithm use what? For future. If the pages are not used in the future, then will be victim. So will be, as name implies, definitely is optimal. That is the best solution. The problem is hard to see, hard to find which page will be used in the future or not. That is the biggest problem. So this one usually used for reference, which means I have a new idea for such a page replacement. So you should evaluate your algorithm. How can you evaluate? By running your algorithm compared with the optimal. Optimal is the ideal case. So it's almost the same or little bit more the page fault on average. So mine is better than the other one. Or nowadays, using the accounting information, which means the coordinating resource usage. So by analyzing such a resource usage and some prediction algorithm, you can actually estimate the future pattern of such a to utilize optimal algorithm. So I think that we discussed about the value algorithm. Is instead of seeing the future, it's hard, almost impossible. Why don't we take a look at the past, right? the current is based on the past. Using the idea of the past, knowledge of the past, we can actually prepare for the future. That is the objective one. History. Okay? That's the reason we are learning. I believe the history is very, very important even in the computers. In my opinion. Anyway, by taking look at the past, so which will be the victim? If least used, never used within a certain time, it will be victim, right? So in this case, so 5 need 3 pages at the time. So 1 is referred here, and 2 is here, and 3 is here, and 4 is here. But 3 is least used. So we can select the 3 as the victim pages. Okay, that's the idea of the LRU algorithm. The problem of the LRU algorithm is what? For each page, you need to manage the history. Okay, so one way is we can use the counter. The counter, some of the operating system provide counter as a hardware instruction. So we can use for each counter for each the page. So this time the 3 is, so every time period it will be increased. If the page is left, we use then reset to the 0, then increment the value by 1. So then, for example, this time if 2 is accessed, so it's accessed 1. 5, there is no 5 over here, we can just select the highest count for the victim, which means, so 4 period time never used, referred, right? So this will be least used one. And LRU algorithm is used a lot for memory buffer management, specifically in the database. The database, as if you are taking the database course, so there are 2 ways to increase the speed of searching the data in the database. One way is you can use index. So using indexing structure, you can speed up searching the database. Another way is cache, the memory. So you can use the memory, big size of the memory, to increase the speed up. Instead of accessing the data hard disk drive, you can go to the memory, then use the cache information. That is the main purpose of the cache, just like the other cache the mechanism. What is the hit ratio of such a database search from the memory? It's 99%, 98%. Okay, which means 1 out of 100. Okay, only access the hard disk drive. The other 99, you can access find the data from the memory. It's so fast. Okay, so to do that, you need to manage the cache information. Actually, it's a buffer. It's called the buffer. Number of buffer using LRU algorithm. This is ordered by the least entry used. Another way of implementing the LRU algorithm is using the step, because the counter need for each. What if we have the millions of the page frame? You need the millions of counter. Excuse me. You need to increase the value for each. So it takes a long time and resource. So instead we can keep the stack. What is the A stack? The data structure. What's the different from the pi? What Q? Q is first in, first out. The stack is first in, last one. You can stack up. Okay, there are usually 2 operations. One is put, another one is pop. So that is a step. So which means, why don't we use such as, if we use a step, if the certain page is used, you can put in the step. Then if there's another page left, you can step up, which means this one is the oldest one. If this one is referred, used, you can take out and put in the top. So we can use only one data structure step. Is the Y, the counter need number of counter of what? The page number. But this time we need only one step. Okay? So this is a step. So we are going to manage the n plus 1 the step. Okay? And we can stack up. So this is the top, this is the bottom. We can put and pop out. So there is a operation to pop out, not from the top, from the bottom. Okay, to find the least recently used one. So for example, 1, 2 is leopard, 3 is leopard, 4 is leopard, which means this is the least used one. This is the most used one, recently used one, right? So then when, so for example, 1 is, in case 1 is leopard, we can take out 1 to the top because it's the recently used one and old one. And 2 is leopard and bring the top. So when we look for the 5, so we can stack up 1. There's no 1 is here. Okay, so we can bring the top. 2 is here, bring the top, and 3. Okay. This time 3 is here, so we can bring to the top. Okay, like that. So whenever we need the space, so we can bring the page from the bottom of the step because it's the oldest one. So this is the implementation of the error evaluation using the step. This is another example of the same thing. Okay. However, anyway, we need the size of stack. We need to specify the size of stack, which is the same as the number of available page frames. Okay. Somebody may be curious. So it makes sense to use the LRU algorithm least recently used. Does it? Is it always true? The old one will be the less chance to be referred. If we think about the opposite way, so because it's never used, so it's a higher chance. Anyone who go to the casino? So I can play only the roulette because I don't have to do anything. Okay, just the betting, the number or the even one. So I like the very simple. The problem, like the binary problem, odd number, even number. So at the time. So probably you take a look at the number, history of the number. If 1 is never used for a while, or the old odd number, then bet to the even number. Right? So that is the opposite of the least recently used. Because it's never used, never referenced, why not? So it's a higher chance. So most recently used will be, because it's for example, if you see the 1 or the odd number, the even number will be higher or other than that. So may not chance to get another 1, right? So that is the idea of most recently used as a victim. Does it work? Actually not. So for example, in the roulette, in the casino, so you see this is a history. So 8, 6, 4, 2, 10, 12. So all even number. So probably next one is the odd number. So you bet the even or odd a lot of money. Does it work?
Yes.
Yes?
Yes.
Just one.
Yes.
Don't try. Why?
Because I think sometimes casino has a rules.
Rules?
Yeah.
It's random selection.
It's a random?
It's not really random, I think.
officially many. I heard that the dealer may control not exactly the exact spot or exact number, certain area the dealer can control. But anyway, in terms of mathematics, statistics, it's a independent case. So if you roll your dice, okay, even though you got a lot of the even number, there's no relationship with your rolling a dice. So which is called independent case. So which means it's still hard. Even though you got a lot of, so because it's independent, there is no relationship. But most of people expect, because you don't know history of the other. Overall, if you consider such a thing, it will be 50-50. But it shows just a part of. By considering millions of cases, definitely it's a 50-50. So behind this history, probably a lot of odd numbers. Okay? So it's an independent case. So it's still 1/2. Really?
When I play this game, I only bet on the number 0.
Number 0?
Yeah, because the percentage of the number 0 is 1/32. But if the 0 shows up, the dealer gonna pay you 35
Yes.
times of
Right.
your money. So
That's the way to hook up the people. Anyway, the overall, they don't care whether you make the money or not. So overall, the casino said their winning rate is 1.2% higher than the guest gambler. So usually 51 to 49. Okay, so doesn't matter whether you use such a technique. Well, everybody has, but in terms of statistics, so it's if you play forever, you lose the money. But there were students from MIT who find the weak point of such a casino program, so they actually make the money after defining their own strategy. Okay, but they actually the casino prevent them to come to the casino after that. But if the dealer can control the rolling of dice or the rolling of ball, okay, which means they can have the certain probability to put the 1/8 of the area of the roulette, okay, and it's a different strategy. So everybody believes it's such another strategy. So which means if you can see, it's a random, it's not the sequence number. You may see the 0, the 31, or the 4, something like that. I cannot remember the number, but sometimes the die go to a higher chance in this area. So you can bet this number. Okay. Even I don't want to think of such a complicated one. Just see the bar, history bar, then the even one. Anyway, so most reason to use one can be also used. But at that time, basic assumption is it's a uniform reference. Okay, and email. So error algorithm is not easy to implement. Not easy means more expensive. So is there any other way to simplify such error algorithm? So to address that one, there is a LRU approximation algorithm. So LRU approximation algorithm do not consider all the history of for each page. Instead, each page has the 8-bit coding. So one by so 8-bit the structure. So for example, if this is we have 3 pages. So it's a 1 byte, it's 8-bit. If this one is left, then this is set as 1. Okay, the other will be set as a 0. Okay, then 2. So 2 is then we shift this one 1, 0. And this one is 0, 1. And this one is a 0, 0. If next time the 1 is leftward, then we set 1, 0, 1, the other 0, 1, 0, 0, 0. Okay? So first, whenever if the page is leftward, use then shift to left. Then at the leftward, the page is gonna be 1, the other will be 0. Then when you select the victim using the LRU algorithm, so for example, if you see the 1 over here, 1 means it's a used, okay? Used. This one is not used, this one is not used. Highest number means what? So in terms of binary, highest number means it's a used, okay? The lowest number means it's least used, okay? So that is LRU algorithm, but it's limited by 8 term size of the bit. Okay. So how we can speed up LRU algorithm using this approach? Because in the instruction assembly language, or even the C language, what is this? You can actually shift to left, shift to right. Shift operation is one of the fastest operation. Okay, for bit the processing, shift left, shift right is one of the fastest operation. So we can speed up such an operation. So for example here, so more essentially shifting most recent reference bit into the higher order bit. Oh, it's the opposite. So if this one is used from the right hand side, okay, more and left hand side, most significant bit. Can you remember your microprocessor or assembly language? Left hand side is the most significant bit, and right hand side is less significant. Why? Because it's a 2 to the power of 7. It's a bigger number. Okay? This side is 2 to the power of 0. 0 or 1. It's the least significant bit. So we are going to start from the MSB. So if this one is left of 1, otherwise 0. And shift to right. Okay? So it's opposite. I'm confused. So which means if this one used recently, the value will be 1. So because it's the most significant bit, higher number, so you can just check which one will be the victim. The lower number will be the victim. Okay? It's easy to check just which one is the highest one. You can just check from the MSB. Okay? The 0, 0, so this one. The next bit, 1. So next 0, 1. So this will be the victim. Okay? So it's very fast. But it's limited by number of bit. Okay? So in this case, 8 bit. So if you have the 16-bit processing, it's the 16-bit. So or the double word is a 32-bit, something like that. But it's limited by. So that is the reason it's a LRU approximation, because how much this is the period will be limited by the size of the reference line. So the next one is, anyway, so LRU is working very well, but it's expensive in terms of implementation. So we try to simplify. That is one way. Another way is actually, so it's a second chance. It's a clockwise, counterclockwise, whatever. So second chance the page replacement algorithm, which means, so if it's kind of what? It looks like linked list, right? They are connected to each other. Okay? Each one has a reference bit, which means if this one is a reference, just set 0. Otherwise, 1. Okay, then you start from the previous one, previous victim. So in case of the just starting up, you can set one of them as a start the point. So from the start point, so you can check. So let's say that one is a starting bit, starting page, check. So we will, let's see, each one is 0, each one is 1, and you want to make sure. So 0 means it's not reference, right? So we write it from here. So let's say that this is the starting, the victim. So from that, we try to go follow the linked list until we find the page that has the 0. Okay? Because 0 means it's not reference. So circular pattern. So in case all of them are referenced recently, okay, all of them are 1, so it's a 1 cycle. Then the whatever the reference bit is, the next one, so that page will be selected as a victim. Okay, so how many times? Just 1 cycle. Just 1 cycle of the read we need. So using such a second chance page replacement. So if this one is the reference, then it will next time it will be set as 1. Then start from the next of the previous victim for the next to find page replacement. And go to this one, go to this one. That is the second chance. The page replacement. So enhance the second chance algorithm is this is the same as the reference bit, and the next one is we will keep the same idea but some modified one. Whether the page contents is just not just the read, but if that is modified or not. So 00 means it's not the recently used or never modified, which means it's the best chance for the victim. Right? Because it's not used recently, and also its data is not changed. Data is changed means, modified means it's accessed. Okay? So this recently accessed the page, you'd better keep. Okay? So 01 means it's a recently used, not recently used, but it's a recently modified. So we'd better keep. And 10 means it's a recently referred, but it's not modified. And 11 means the recently used and modified, which means it's a higher chance to be used. So we try to find until the 0 or 0, or 0 or 1, 1 or 0, 1, 1, using circular pattern. Okay? That is the enhanced second chance algorithm. So you probably realize most of these algorithms rely on certain period of time. Okay, next time. See, millisecond is the 10 millisecond, or it's just the 1,000 second. So how can we consider such a period of time? At the time we need the counting algorithm. Okay? So such a counting algorithm, there are two parts. One is a least frequency used algorithm and most frequently used algorithm. That's already discussed in LRU algorithm and most recently used algorithm. But nothing but it's a counting. Not instead of time, it's a counting, number of frequency. Because the counting, it relies on the time, so hard to implement. Why don't we just count number of the page reference page or the modified pages and so on. that is the page replacement. Anyway, so main purpose of the using memory is we try to speed up to access the data, okay, from the CPU. So we have this. Also, because there is a limited space, limited device, we try to maximize the utilization. Because of that, we propose the page-based, the memory management. But it's still limited, so we learned about how to replace such a pages. So another way to speed up the memory management is for the pages. Probably we need to search the free pages to use the memory space. Why don't we keep the pool of such a free page? That is called the page buffering algorithm. So keeping the pool of the set of the free space, so you can allocate whenever needed. There are different ways of allocating the page frame to the process. So not all operating system, actually the operating system does not allocate the all page frame that are required by the process. Instead, minimum the page frame, because no matter how fast your CPU processor is, anyway, the first instruction should be executed, and next is instruction, then another page. It's on-demand paging. So we can allocate a minimum number of pages first. For example, IBM 370 allocate 6 pages, something like that. Also, we can provide the priority for the pages. So some of the pages are the important at the time you can keep in the memory. Okay, for speed. Global and local allocation means it's shared by several the processes. Okay, and the local allocation is only for that memory. Tracing means the worst case of the paging is in terms of page fault. So you have the 1, 2, 3, 4, 5. So you have 6 instruction. Your instruction based on the instruction, you need the 7, 6, 7, 6, 5, 6, 5, 6, 5, like that. Okay. So using certain algorithm, so you select this one as the victim. So 6. The next one, so if you are using the people or whatever, so this other one will be the victim, but suppose that this will be selected again. So take time. This may be happen, okay, in certain cases. So this is called the thrashing. Even though we have the enough space, only because of the certain pattern of the instruction, you may replace every time such a pages. So that is called the thrashing. For example, here, okay. So this is a for loop to add up the 1 through the 100,000. So we have the 4-page frame. So each frame has only one the memory. This is A main, X B. So maybe this loop you need I, right? So you need to find the victim, but for example the X, then I, then you need the X, so you need to replace I, right? So it's a key. Okay? So that is for the duration. At certain time, the CPU utilization is decreased. Why? Because CPU does not have a time to compute. Instead, because of a lot of page replacement, page fault. So to address such a problem, so we can group the pages that are working together. Okay, that is called the locality model. Okay, so this is the visualization of the such a memory address, and their data. So it can be actually the group by such a locality. So we can reduce. Using such a working set grouping, we can reduce the page fault. example of the memory management in the operating system. There are other issues of the page, but most of the issues in the memory management focusing on how to speed up the processing. Okay, so page table size and the page size itself also the issue. It should be optimized, and sometimes not only such a hardware issue, but sometimes it's a program issue. So there are two examples of the programming. One is the J and I in a loop and assign the value for the zero. It's initialization. Okay, it's ing. Output is the same. However, in terms of page fault, this may cause up to not always, up to 128 times 128 page fault. Why? Because the J is in the array. Even though you have the two-dimensional array in the programming, that doesn't mean you can have the two-dimensional array in your memory space. Instead, it has a pointer I first, okay? Then I has the sequence of 128J, and the 1, I equal 1, I equal 2, I equal 3, up to 127, 0 to 100. Then you have J. But if you access J first, okay, it's a page fault. Okay, you understand? If you, so this is for example sequence of the memory address. So I value 0 is a pointer, 1, 2, 3, and the J is here. J is here. But if you access J first, then this one, page fault, then this, page fault, then this, page fault, then this. Instead of the if you access the I first, page fault, then without page fault you can access the data. So that is the reason. Probably you heard from your instructor when I'm not sure the Java whether it affects, but C program definitely this is not a good example of the code. Okay, so you need to do the bottom type of the program. So outer loop should locate it the left-hand side first, because of the page fault. Okay. Is it 11:45 or 12:15? I always confused. I thought it's 11:45, so I speed up. Okay, so let's. We have the 20 more minutes. Let's review. So final exam will cover the after midterm, that is chapter 7 through the 13, and as did I announce, the final exam will be in the Dana Hall room 107, not this room, okay? Which will be the Tuesday. I cannot remember the date. What is the date? 9. December 9, 10:45 to 12:45 in Dana Hall 107. It's a big lecture hall for your engineering 400. Okay, so at that time, the exam format is the same as the midterm exam, the 30 to 40%. Do you want more multiple choices? No. Not always the multiple choice are easy. So probably you feel the same thing. It's generally the average of the multiple choice is not better than the open-ended question. Anyways, it's gonna be 30%. Otherwise, it's very hard to create. So if I ask a question for all the open-ended question, it will take several days to create the average sheet. So probably 40%, I think, the multiple choices. The others are open-ended question. I'm thinking this time, because you have the 2 hours, so more questions, like around the 5 question, open-ended question. So deadlock is part of some of the students actually confused because this is the part of the process management. So just skip this part, but this is the our exam. Our exam covers the deadlock. Okay. In the deadlock, at least you should know what is the requirement of the deadlock. Okay. So it's a full requirement of the deadlock, like the characterization, the mutual exclusion, golden weight, no preemption, and circular weight. Okay. Then we use the resource allocation graph. So you should be able to understand what's going on in your system using the resource allocation graph. Then this is the notation of the such a graph. For example, this one. So in this example, if we can find circular weight, it's not always okay. It's not always the deadlock. So because we have the multiple instances, so you should be careful to understand this. Okay. For example, this one is not, even though we have the circle like the P1, R1, P3, R2, but this is not the deadlock situation. Okay. So there are different strategies of the deadlock. One is deadlock avoidance, deadlock prevention, deadlock detection. Okay, slightly different. So prevention means you can break one of the characteristics. Okay, golden weight, mutual exclusion can break one of them. For example, I can give the unlimited resource. Then there's no deadlock, so you can prevent actually that. And deadlock avoidance, you can avoid the deadlock by finding the safe state. So at the time we learned about the Banker's algorithm. Where is it? Not this one. So we use available, max, allocation, and need. So if we can find the sequence of the processes which makes the safe state, so then we can avoid the deadlock. This is an example of the Banker's algorithm. I like this kind of style question, definitely. That has the kind of math question. Then you should be able to understand the algorithm itself. Do not solve such a problem with your mind. Okay? Your hand is much better than your brain. Please, practice with your own hand, please. So every semester after the final exam, couple of students come by me. So I got the straight A so far, so I'm the genius student, but in this exam I understand every algorithm, but because of my mistake I got the lower point. So do you think such a appeal can be excused? Definitely not. Please. It doesn't matter whether you are a good student or a bad student, you straight A student or the straight F student. I will decide my final grade based on your score and your code. Okay, so that is the main part of the deadlock. So next one is the main memory. We already did the So you need to understand the basic mechanism of the memory management, main memory management. There are two parts. Okay, one is the main memory management, and since we have the limited resource, we should have something data structure that is a page. Then, so using such a paging the data structure, we can actually have the page replacement algorithm. It's a virtual memory. Okay. Virtual memory is not nowadays a swap space. It has been used for the swap space which means it's a swap in and out. Entire process in the memory will swap out, then you can swap in the new process. But nowadays it's by page, page in and page out. At that time, why don't we keep the virtual memory? In terms of data structure, it's the same as the main memory, but it's located in the what? The hard disk one. Okay? Then you can just consider the page in and out. However, we have the very limited page frame in the physical memory, so we should have the algorithm. So that is a page replacement algorithm. But in the main memory, you should allocate such a memory. Many part of this main memory management actually discussed in the computing architecture. Okay? So if you already took the computing architecture, it's much easier to understand the addressing in the memory. Okay? Like a base and limit